Okay, from the previous video, I showed you how to create the machines, those HAAS machines. Next is to create a simulation post-processor to simulate this machine in Cimatron. To do that, you need to go to our FTP, go into this folder here, and go in the post-processor, GBP2. And you need to get a copy of this DIY post, and then you need to unzip it, and let's delete this one. We don't need this one. Yep. And next is to rename the post. Make sure you rename all the files to the same name. You can key any name you want actually. This will be our post-processor for the simulations and the output. Okay. So afterward, you need to make a copy. You need to copy these files into this folder. You need to copy into this folder. So let's make a copy of all the files. Copy. Okay. So we have a few files. Let's close this. For the simulations, most of the time we will edit this MCFG file for the machine kinematics. So after you import, then at the machine side, you can open up the machines and set the post processor to your machines. HAAS, there you are. Then save. This will allow you to call this post processor when you load these machines automatically. Okay, after copy and rename the post and copy into this folder, next is to edit the MCFG. If you want to just simulate the machine in Cimatron, you just only need to edit this file only. So this file is a text file you can open with a Notepad, right? It's a text file. Oh, for me, I prefer to open by the Notepad++, just in case you need a copy of the files. So just go to this folder of the FTP and get this and unzip it, and click on the exe file to open the Notepad++. So this is my Notepad++. Okay. So after you opened, you need to make sure it is this one, GPV2PGF. I've customized a special template for this, and the display will be much more better after you activate. So for this post, we have 3 group to set. Now let's look at the startup parameters. For this post, first, this is a version number. The DIY post version number V141. Okay, V14 means Cimatron version 14. 1 is the post version. And next, okay, this line here, okay, make sure you set always 1. If you put 0, all all the parameter in this file will not affect, okay, will not be effective. Will all set to 0. Yeah, so put 1 here, and this is the machine name, so make sure you can key any name you want. Yeah, users, we leave it. Yeah, you output the login username by default. And if you key in something, then the username will be this name. Machine kinematic, yes, this machine here is actually a 5-axis table, so we need to choose number 2, 5-axis. And how about the save move option? There's 2 save move options. One is to just move Z only, in case you want to move move to save position. The other 2 is move Z and then XY. So 2 will be much more better. So we'll set 2. And this parameter here is for table head or head, so let's leave it. TCP, move to 0 before TCP. Okay, some machine need to do that, but most of the machine no need. Yeah. So for this machine no need, we put 0, and for this machine don't support in TCP also. Yeah, just 0. Now let's look at the machine kinematic parameters. Okay. First one, of course, is 2 directions. So 2 always at Z plus. Yeah. Unless you have a spatial machines. Next parameter is this one. So define rotary direction by vector, yes or no. Okay, most of the time we just put 0, no need. Yeah, no need. If we put 0, that means we just need to set this parameter here, not this one. Okay, this one will be ignored. So for this machine is X plus, right? So we put 0 here, and this is X plus. So if you look at the machines, A-axis property is X plus, right? That's X plus. Okay, and the rotary collector here is A, and the tilt rotary positive limit 120, and the negative 120. But for this machine, because the Y plus travel is more than the Y minus, so we'll force it to work on the minus side only. So by setting 0 to minus 120, and rotary step angles, if this machine is not, the rotary axis is not indexing, so you put 0. Alright, if this is indexing angle, indexing axis, you need to put in the index in each angle step for the indexing. Yeah, so 0. And prefer angle, rotary prefer angle number 3, negative side. Yeah, this is for the tilt rotary. And also the tilt rotary center is minus 50.8. Right, so as you can see here, this is 50.8 minus 50.8. Then we go to the C-axis, or in this case is B-axis. So the non-tilt rotary will be the Z minus direction. So if you check at the B-axis here, there's a minus, Z minus, okay, and it's a B. Normally it is C, but this machine is B. Yeah. So minus. Okay. This one we can ignore if we don't select set by the vector. Yeah. And this is the collector for the non-tilt rotary. Normally C, but this machine is B again. And the limits, yeah, if you put minus 180 and plus 180, that means this angle here will not exceed 180. It will always between minus 180 and 180. You can also set 0 to 360 also. Then the code will always add between 0 to 360. Yeah. Shorter path, yes, this one. Okay. If you have test the machine and the machine is continuous simple, or in other words shorter path, okay, then you just set 1. If non-shorter path, set 0. Okay, so I'll skip this one, and this one you understand is 0. This rotary axis is continuous. And for this non-tilt rotary axis, we don't prefer any angle, right? So we just put it at 1 knot, and that's it for this. Save. Okay, now just in case you need to set the rotary axis by vector, just in case you need to set it by 1. So if you set this one to 1, that means this will be ignored. Then you need to set the vectors. The first, this is rotary vectors, tilt rotary direction vectors. That will be again this is x plus. Okay, and then you need to define a vector normal to the tilt rotary axis and the z-axis. So in simple words, that will be the y plus. Yeah. And for this non-tilt rotary axis, this is the vector, so you need to set to -1 for the z, right? And also you need to set a vector represent the projection of the tilt rotary axis projected to the taper face. Okay, so the tilt rotary axis direction is x plus, so project to the face, it will be x plus. Yeah, that's why x plus here. So that's how to set the vector, just in case you need to, right? For this case, most of the time we just put 0. We set by the collector here. It's much more easier. Next, we'll look at the machine limit and safe position. Let's minimize this and open this. Okay. The first thing you need to set is set the XYZ linear axis limit here. So this value here is same as your x, right. Go to property, x-axis, yeah, the minimum and maximum. So you can look at here, axis, so minimum maximum for XYZ. Right. Then the two change safe position. This will be the safe positions. Okay. Normally we set at the position of the two change, or you can define other place if you want. So in this case we set like the x value is the same value as the x machine minimum. X machine minimum is, so the position is here. For the x is x minus max, and x y plus maximum, and z plus maximum. So for the rotary, we by default we just set 0. Okay, the next parameter that's important is this one. Okay, this value is not important for simulation purpose, for just simulation. It only important for the G-code output. Okay, so this value will affect the Z53 XYZ value, or M91 XYZ value, or the super XYZ value. So you need to check properly what is the value here. So you need to check the rotary table top center. What is the Z53 value, or the M91 value, or the super value, or in other words, the machine position of that point, and just key in the XYZ here. Okay. So for example, this one, I key in for the Z minus 362.3. Okay, and for this Z maximum is 362.3. So this one, this value plus this value, it will be equal to 0. So if this is a finite machine, to move to Z maximum, the Z53 Z is 0. This is how we use this one to control the machine position value output. Okay, so that's the last parameter that we need to set for this MFG. After you edit the MCFG file, next is to create a new MC file to test the move. Let's switch to CAD mode, and I will just sketch a box with a width maybe 50, and the height maybe 20. Because this is quite a small machine. Right. And okay, get extrude 20 will be fine. Yeah. Okay, so after I create this one, normally I will create some CS as well for indexing, testing of indexing. So I will use this CS normal to plane, right? So I'm going to create one here and name this as a X plus, right? This will be the Y plus, and this will be the X minus, X minus, and this will be the Y minus for testing. Right? So after you've done this, and the model uses the default is our machine 0 point, okay, our default. If you want to change it, you also can, but for testing, you just use this one. Yeah. Let's switch back and see. And after you've done this, next is to set up the NC setup. Yeah, NC setup, and choose a machine, your machines. Is a 5XTT HAAS, this one, yeah. So let's put this 0. and then OK, right? And by default it should load the post as well, you know. For some reason, if the post is not what you want, you need to manually change to the HAAS post that we create just now. HAAS DF260, this one, yeah. Okay, and also okay, this is the post, right? And for the post we need to set it to set some post parameter. Let's edit, and if we want to open so this is the post parameters. Post mode plug, that means this mode you need to have a register dongle to run, Cimatron plug to run. Demo, it will only run by 88 lines, okay? More than that it will stop. Yeah. So for machine simulation, you just only know, if you don't need to output the Z code, yeah, and just go to machine simulation mode. Let's set this, yeah, and this is how it's set, and we can show the table. And yeah, we have some mistake, okay. We don't set the rotary table to table group, forgot to do that, so you need to go back here, go to this b-axis table, and make sure it is under the table, right, and save. And let's try again. Let's OK, and try again. Now it's okay. So now you can see that the reference point will be the tabletop, right? The tabletop, and of course we cannot put our part there. So here is for you to offset, right? So you can use this arrow to click this one to make it offset this value if you want, right? So for all, you can just use 0. I think I will offset this one by 150. It's 50 a bit high, and maybe but if you put too high, when you rotate, you might face all limits, so you must adjust properly according to your machine. So I think okay, we should, okay, 150 is okay. Okay. After done this, then of course you need to create a part for the simulations. So I will select everything. Make sure you are using the model UCS. Yeah. The setup, make sure you set according to the model UCS, the UCS model. Okay. Don't use other. Let's use model. This will be our machine 0 point. Right. Okay, now let's create some profile to test the move. Let's create 2 parts. This is 5-axis super. Sure, I'm going to use the model UCS as a machine 0 point. It is okay. And make sure you create a bonus tool. This bonus tool, 6. Clearance repeat 15, and the holder is this one for the simulation. And then I'm going to create a procedure, so I'm going to use a profile close contour. and make sure it's model UCS. Okay, this define which UCS you are working on. So I'm going to choose control, choose on, or choose toughness. Right, the starting point is okay for me. Let's continue. And how about the motion parameters? The approach I set as 0, 0. And the top I will set it to 1, right? We are not doing any cutting, so just put on 1, and just in case you need to do this testing on a machine, you can always set this 1000 feet 2000, no coolant, right? Because no cutting, it's okay. Okay, to create the top. So this toolpath will test test for what? So it used to test whether the operator have set up the part 0 point, the work offset correctly or not, or the tool length correct or not. Okay, by this profile we can know testing this profile on the machine. And next we're going to create some indexing. For example, the X plus, so we always change this one to X plus. Yes, and of course this is a different profile, so we need to change it. Reset, right click, reset. Yes, reset the previous one, and we're going to choose this one. I don't like the start point to be here, so I'm going to change the start point to the UCS positions here. Right, so this is what I want. The rest no, reset is the same as the previous. And calculate. Oh, and it changed the control. Changes to on. Right, and I'm going to make this copy for the Y plus. Let's change the Y plus. Yes, and let's add it. Contour. Reset this contour, and we will select this face here. Right, so start point, I'm going to add it, change the start point to the UCS 0 point here, and okay, and again need to change that to on. I forgot to do this. Is right, and for the other two, we'll just make a copy, control copy, and paste here, and just change to X minus and the Y minus, right, and then execute. The geometry no need to reselect, it's the same. Right, so then this is all the profile toolpath that we needed to test the movement. Save profile. Next, let's check the machine simulator to see our machine set up properly or not. Yeah, and click OK. And this is the machine simulator. You can click here to display this thing, right? Of this, make the display better. This is simulation control. This is simulation control. You can click to see what happened there. if you're new to this. Yeah, and immediately I can see that some problems here. My part should be above the table by 150, but this is not doing so. Why? Okay. So after some checking, I found out that during when we create a machine simulator, we done some mistake, right? We have created the B-axis, but on the B-axis we forgot to create the workpiece assembly, right? So we need to add it back. Workpiece. Select workpiece, then OK, and then save. So you should have one tool assembly and a workpiece assembly. Let's exit and reload the simulator. Yes, exit. And let's reload machine simulator. And click OK to load it again. Okay, now you can see there's the part position is correct now. Okay. So if you don't want to see the UCS, you can press the middle and right button of the mouse and click this off the tangent, right? So normally I want to see the lines also. You can put a trace if you want, do a tracing, right? So here you can go step by step, like a single block on the machines, right? Step by step move, right? Step by step, right? Or you can set the speed and just play. So by default, because on the machine CFG, we set A axis limit to A0 to A minus 120. That's why it always work on the minus side. Right. So we need to see whether the movement is there anything funny or not. Okay, so what we can see here, the simulations is correct. Okay, this also means that our MCFG file setup is correct. Okay, from the simulations, our machine is set to work on the A minus side, and let's say I want to, and the machine limit is A0 to A minus 120, and let's say I want the fault procedure here. I'm going to change it. I want it to work. I'm going to force it to use A positive side. Okay, this is how we force the machine to move. Okay, and let's check whether it moves or not. Okay. This is minus side and minus side, A minus side, and this is also A minus side. The last one also A minus side, but we already set it to the A plus, so it is not functioning because inside the MCFG file we already set the limit to 0, A0 to A minus 120. Okay, just in case you want to allow this to happen, so what you need to do, let's exit you need to go to setup and edit the post parameters. Right, so this is the post parameter. There's some post parameter here for 5x only. If you have 3x machine, this will not work. This parameter will not work. So let's look at this one. Yeah, tilt rotary plus limit and tilt rotary minus limit. So default value is 999. There's a 59 here. Okay, so if you key in 59, that means it will use the default value inside the MCFG as a limit. So in that case, it's 0 and minus 120, right? So, and now I want to enable this post, this machine to use the plus. So I'm going to increase it. So you just key in the value here. 120, right? So if I put like this, so I manually set, okay, the max rotary plus limit to plus 120, and the minus one is 99999. For this value, it will use the default on the post on the MCFG, that is minus 120. So currently the limit is plus 120 and minus 120. And click OK, and let's test and see whether the last procedure it will go to the plus side or not. Okay, so let's rotate, installation, zoom up, and do the simulation. So start work on the top, and 1, 2, and 3, and the fourth one it will go to the A plus, because we already forced it to go to A plus. And yeah, because the y minus side, the y travel is smaller. Okay, so it's over limit. Okay, this is why we need to set the machine limit in the machine builder, so that if the position over limit, it can let us know, right? So you can stop it, or we just continue, right? Okay, this is plus. Okay, next rotary parameter that I'm going to talk about, this one, prefer tilt rotary angle. Yeah, you have option default, non-positive, negative. If you choose default, that is the default preferred directions of the tilt rotary that you set inside the MCFG file, right? And if you somehow, if you want to change it, you can change it from here if you need. Yeah. Next I want to talk about rotary segment, right? To show you what is rotary segments, let me change this one to maximum 360 first, and do a simulation for you to see. And let's go to simulations and click OK. Right, let's look at the rotary segment. And display motion. Let's skip the stop. Okay, you look closely and let's show the coordinate, the block here. No need. You can see the rotary is rotate, okay, from A move to A minus 90 is only one segment because I set 360, right? So, and this angle is 90, so it is less than 360, so it will not break it into several segments. Okay, there's only one segment move. So next I will change the pulse parameter, and let's go to pulse. Let's adjust the segment, angle segments. So I'm going to put it to 30. The default is 30 actually. Okay. So this means that I'm telling the pulse if there's a motion, a rotary motion more than 30 degree, break it, so that every motion's maximum is 30 degree. So let's do simulations. Okay. Okay, let's skip the top part. Okay, let's see that. Now you can see that let's display the curve. Right. So now you can see that the 90 degree movement already break into 30 degree per movement, second, third sections, right? So this is good for when you're doing a test run on the machines, right? Because and you running single block, okay, single block and doing test run on the machines, so that the rotary will not turn more than 30. Okay, step by step. Now we're going to talk about connections. If you don't apply any 5-axis connections, this is the 5-axis connection. Procedure. There you are. Connections. This is 5-axis connection. If you don't apply this connection manually to connect from one UCS to another UCS, then the post will automatically apply the default connection for you, right? So let's look at the simulations. Trace. Yes, trace. Okay, so the program will always start from the safe position that you define inside the MCFG, the safe position, this one, right? That is somewhere here. right? You go to save position, and then from the save position you move X, Y, and then go down in machining, right. So, and if the rotary going to move by default, Cimatron will apply long connection. The post vessel will apply the long connection. What is long connection? Long connection means that the machine will, before a rotary rotate, it will first move Z to the maximum. Okay, that's the summary here, the maximum, right? The limit. Yeah, move up maximum and then move the rotary. Okay, move the rotary. And then move XY to 22 and then go down and start machining. Okay, this is called long connections. Yeah, it will only move the Z maximum. This is the default. Yeah, long connections. This is the default value is 2 chain, so switch to safe position. So if you want all the long connection to move to the safe position, then you select this one, long connection. Okay, every connection, that means it will include the short connection also. So I will choose long connection and do a simulations. Let's look at how it moves. You can see after every card, it will always move to the safe positions that you define. Safe position, you will first move Z to up the maximum and then XY to the safe position. Right, let's change to 2 chain. So if the default option 2 chain, that means the program will have safe connection, long connection, and short connection. So what is short connection? So this short connection angle, okay? If you set 30 degree, and if the Cimatrons find out that your rotation angle is target angle is more than 30, then it will automatically apply the long connections. Okay, if less than this angle, you apply the short connections. Okay, so what is short connections? Let me increase this to 180 so that all the long connection will become short connections, because all the rotation in my program is 90 and 180. So it's smaller than 180, so the post will apply the short connection instead of the long. Yeah. Let's simulate to show you what is short connections. Start from save. In machines. Okay, and machines. So as you can see, the tool now don't retract Z to the maximum, right? So this is called short connections. So the short connection, you will check point 1, point 2, which one is higher. The Z will move to the highest point of either point 1 or point 2. Then you will move the rotary. Rotate a rotary and then move to XY of point 2, right? So that's short connection. Okay. Short connection angle, normally the default is 30. Okay, so for 30 it's okay. If you put more big angles, of course there's always a chance for the tool to hit the part of the features. okay, for short connections. Default is 30. Now I'm going to explain this 3 parameter here, right? So if this 3 parameter you put 999999959, that means the safe position of the XYZ of the two, the safe position will be the position that you set inside the MCFG, this one, the default one. Sometimes you already know where's the default, okay? Yeah, I'll show you where's the default. Let's change to every connections, okay, so that I can move every connection to the safe. Now you can see that the safe position is somewhere here, so you always move the 2 to somewhere here, okay? So what if you want to change the safe position instead of here, okay? I want the 2 to move the other side, okay? So let's exit. Let's change the pose. And let's look at the X, okay? Safe position, okay, from table top center. The reference point must be from the table top center, okay? So by default, the X is set to X machine minimum. That's this value, so it's minus 381. So I'm going to change it to plus 381. Okay, so here I will change it to 381. Okay, the rest I will use a default. And last, do a simulation. And you can see now the safe position for the X already changed. Okay, so next we're going to create a Fax procedure to test the Fax move. Make sure this is model, okay, and go to procedure and Fax productions and use that bonus tool. Yes, and click here to click on the SS. Okay, and then we're going to use a projection curve. So projection curves, and I don't want the two to touch the part, so I'll put the offset of 1 mm. The dry face, I'll select this through here. Right, there's a drawing face, and for the projection edges, I'll select this edge to this one, okay, first and last. Then okay. settings. I think this is good. 2-axis, I'm going to use the default. That's what you see. See here, double check, no, nothing. Link, yeah, the default. Let's use the default, and I'm going to change the retract for the height. Let's put 50. There's also 50. The rest I will set default. Don't set anything here, and this one. And just calculate. So you should have one movement. Make sure you adjust the speed, or else your machine will move very slow. Well, testing 2000, we check this 2000. No coolant, like prefer angle, no. Okay. Right, this is what we created. This procedure, moving from here to the other side. Right. Okay, now look the post parameter, and let's do a reset. Just click on this one, reset to the default, and then OK. And let's do simulations. And OK. Now let's look at how the tool move. Rotate. There's a y-axis limit, so we need to reduce the height. Later we will edit. And let's do simulations. So we'll start from A minus 90. And the default for this limit is A0 to A minus 120. Right, so the rotary cannot go to the plus angle. Right, and because of this, Cimatron will automatically apply a swap. Okay. A two swap. This is called in place two swap. Okay, turn the rotary table 180 and then continue, so that all the A axis angle is always negative. So what if I change the post parameter, increase the default from A0 to maybe 30 degrees, what happened? Or let's put it 45. So I'm setting this parameter to allow the machine to move from plus A45 to the default minus 120. Let's do a simulation again. Let's look at the movement. So again, it starts from A minus 90, the limit. Let's ignore it for now. And move. Then you continue A plus angle move, but until 45 degree that we have set. And then you will do a two lifting. So for two lifting, if you look closer, right, there actually a small radius here, this radius is actually this one, this settings, this radius. I've set 3 mm radius, and approach, this is approach 5 mm, that is the blue color extension. If you look at the screen, this is the approach 5 mm from here to here, 5 mm, and from this point to top is 50. It is set by this one, 50. Okay, so this is what we call a two lifting. So the two will lift up 50, and then the whole rotary table will rotate 180. Let's look at rotary, and then continue the path. So this is a two lift. So if there's a limit on the rotary angle, two lifting will automatically occur. To solve the y-axis limit problems, you can always edit this clear to make it lower. It's under the link, retract. Let me put this element, and it will solve everything. Make this line shorter. Yeah, that's it.